Welcome to AI Frontiers, the podcast exploring the cognitive leap in artificial intelligence. Today we embark on a journey through the latest advancements in AI, synthesizing 27 papers from November 21, 2025. We'll explore dominant themes in LLM enhancement, evaluation, and agentic systems, unpacking key findings and methodologies from cutting-edge research to chart the course for future AI innovation. Welcome to the AI Frontier. Today, we're diving deep into a concentrated burst of AI research, discovering how these papers are shaping our understanding of intelligent systems. Prepare for insights into large language models, agentic AI, and critical evaluation methods. Let's embark on this exploration together. Let's establish a foundation by understanding computer science, artificial intelligence, or CS.AI. This field is the engine room of machine cognition, focusing on creating systems that perceive, reason, learn, and act. It aims to mimic and potentially surpass human cognitive abilities, driving advancements in autonomous systems and complex problem-solving. CSAI underpins innovations from healthcare to creative content generation, and is essential for building more capable, reliable, and beneficial AI. Our first theme this week is the advancement of large language models, or LLMs. Research is focused on enhancing LLM reasoning and their adherence to specific criteria, as well as evaluating their capabilities in human-like negotiation. We're also seeing efforts to improve LLM creativity through novel association rewards, with the overarching goal of making LLMs more reliable and less error-prone. The second major theme is the development of sophisticated benchmarks and evaluation methodologies. This involves creating new benchmarks for multimodal tool use, generating system architecture diagrams from research papers, and assessing LLMs in specialized domains like chemistry. This push for new benchmarks is crucial for scientific advancement and for enabling fair comparisons, driving standardization and rigorous evaluation in this complex field. Our third theme explores agentic AI and multi-agent systems. This research focuses on developing AI systems that can act autonomously and reason effectively. A key aspect is imbuing these agents with explicit models of cognition and cooperation, ensuring transparency, accountability, and effective collaboration. This also includes structuring complex systems with hierarchical task abstraction. The fourth theme highlights hybrid intelligence and reasoning. This involves integrating formal reasoning with data-driven learning, such as grounding LLMs with formal ontologies for enhanced interpretability. Research is also focused on using AI to enhance engineering processes like failure mode and effects analysis, and combining the strengths of symbolic AI with the power of neural networks. Now, let's look at some key findings. Jasperny and colleagues have developed a functional pipeline that translates business process model and notation, or BPMN, diagrams into planning domain definition language, or PDDL. This innovation enables AI to interpret and optimize business workflows, offering practical tooling for business process simulation and automation. The pipeline can generate and evaluate valid execution traces, representing a significant step for practical AI integration in business. Another key finding comes from Zi Guo and her team, who introduced the PAPER-2SYSARCH benchmark. This benchmark features 3,000 research papers and their corresponding diagrams, providing a novel system for standardizing scientific visualization. It utilizes a three-tiered evaluation metric encompassing semantic accuracy, layout coherence, and visual quality, offering quantitative and reproducible assessment of diagram generation models, and catalyzing progress in automated scientific visualization. Minyu Zhou and colleagues have analyzed LLM capabilities in strategic interactions, specifically in negotiation simulations. Their findings indicate that models with higher general benchmark scores tend to perform better, but certain LLMs struggle with emotional and social nuance. Crucially, competitive traits were found to be more advantageous for negotiation outcomes than altruistic ones, offering a new metric for assessing LLM real-world interaction capabilities beyond traditional evaluations. Let's delve into the common methodologies underpinning this research. we see the extensive use of large language models, or LLMs, as core components and evaluation targets. Reinforcement learning, or RL, is widely applied for training specific behaviors and improving efficiency. Domain-specific benchmarks are crucial for tailored datasets and metrics. Neuroheuristic frameworks combine neural networks with symbolic reasoning, and game-theoretic approaches are employed for analyzing strategic interactions and AI safety. We'll now highlight 3 seminal papers. First, Sarah Zuppiroli and colleagues introduce a formal ontology for belief, desire, intention, or BDI agents. This work addresses the challenge of semantically interoperable knowledge for agency by formalizing the BDI model. Aligned with foundational ontologies and using modular design, it was validated by grounding LLMs and integrating with the SEMA's reasoning platform, promising more explainable and cognitively grounded AI systems. Next, Paloma Rabe and her team have developed a method for patient-level information extraction from electronic health records, or EHRs. Their approach intelligently integrates structured tabular data with unstructured textual evidence, using Bayesian networks and neural text classifiers, augmented by a consistency node. This significantly improves prediction calibration by resolving contradictions, paving the way for more accurate clinical decision support systems in healthcare. Finally, Hao Chen and his team propose DAPS++, a novel approach to rethinking diffusion models for inverse problems, such as image restoration. DAPS++ decouples the diffusion initialization from data-driven refinement, achieving high computational efficiency and robust reconstruction performance. This offers a principled understanding for future diffusion-based solvers, advancing capabilities in image restoration and related fields. Looking at the future, we see a continued focus on hybrid intelligence, seamlessly integrating symbolic reasoning and neural networks, and the development of more sophisticated cognitive architectures for agents. Paramount importance is placed on AI safety and reliability, including mitigating AI-generated deceptions. Democratizing AI development through better tools is also key. For your context, AI synthesis in this podcast was created using GPT models, with TTS provided by DeepGram and image generation by Grok. While this content has been human-reviewed, potential oversights may exist. All references are provided. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org. And that concludes our deep dive into these cutting-edge AI papers. Subscribe to our YouTube channel for the latest AI research breakdowns, and stay ahead of the curve with expert-driven synthesis. Never miss an episode exploring the frontiers of artificial intelligence. Thank you for joining us on AI Frontiers.